Welcome students to our learning channel of mathematics. So in previous video, I covered addition theorem and probability, how to work out the theorem and how to apply that theorem in day-to-day word problems when we are going to come across. Here one such one frequently appearing problem in probability I have selected. So probability, it is video number 7. Problem on addition theorem on probability. This is one problem I have taken. Compute means find. Compute the probability of getting an ace card, an ace card, or a king card from a deck of cards if a card is selected. I already told you R option is used for addition. Whenever you find that R connective, immediately you should get an idea that there is an application of addition theorem on probability. As I informed you earlier, to work out any word problem in probability, we follow these 4 stages. So in solution part, first, what is random experiment? Random experiment that you have to identify from the problem. Very simple. What is the activity you are performing in this problem? Selecting a card from deck of cards. Selecting a card, selecting a card, a random card from a deck of cards. So let us continue. The second part is that total number of outcomes. So deck contains 52 cards and all cards are equally likely to get. If you select any card out of 52, any card you may get. Means equal possibility or equal probability will be there selecting every card. That's why total possible outcomes in the deck of cards will be 32. So we can write that is denoted by small n, as I told you. N stands for total outcomes. That is equal to 52 cards. 52 cards. Next, here two cards names are given to you. One is ace card, other is a king card. The next step is that what are the events? Events. Next step, events. There are two events here. One event we name it as A. A stands for selecting an ace card. Same symbol, ace card. And we write K for king. Event name is K. Selecting a king card. Selecting a king card. Just you can name as you wish like this. A stands for selecting a ace card. K stands for a event selecting a king card from the deck of 52 cards. So once you write down those three things, just should have an idea about the cards. Whether you give it or not in the examination, it is better to provide that idea so that the examiner will know that the student will have that will be knowing the perfect concept of that cards. So thing is that here idea, we can write idea here, not necessary but better to give it. So ace card, cards are right, cards, ace cards, king cards, because two are there, two events, ace cards, king cards. So in deck of cards, 4 will be there, no? 4 ace cards. So capital A, capital A, capital A, capital A. One about diamond, it will be diamond. One about heart, ace, club, spade. Any one of these will happen. So 4 possibilities for ace. You make it this card, this card, this card, this card. Color is not mentioned there. Similarly, here also we get four types. We write K, 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 maybe of diamond, heart, club, spade. Out of four symbols, any one king card may appear. Here, a card may be an ace card or a king card. Here also four possibilities. Here also four possibilities. After getting that idea, what are the card positions or card probabilities there or card possibilities? Then we can show probabilities. Probabilities. You give the heading like that. Here, first one, probability of A. A stands for, we can write in words, probability of getting an ace card. Ace card. So, the main formula already I gave you, that is small m over small n. Here write probability of event. If you want to compute probability of any event is equal to small m by small n, where small m stands for favorable outcomes for E. N stands for total outcomes of the random experiment. So here M, nothing but what are the possibilities for getting a star? Just now you have seen four possibilities, and total possibilities are 52. That gives 1 over 13. Similarly, probability of king card. How you write? P of getting a king card. King card. Same. There are four possibilities. M is 4. Total outcomes 52. Here also we get 1 over 13. So in addition theorem we have probability of A union B, means A or B, probability of A, probability of B, and probability of A intersection B, A and B. Now we have given only 2 out of 4. 2 probabilities only we have found out. The remaining 2, how we have to calculate, I will let you know. Next one, continuation step, probability of A or K. This is the thing we are asking you in the problem. It is probability of getting requirement, getting an ace card or a king card. It is from the problem. This we have to find out. This you can write as in mathematical form P. This union, that is equal to this third one, and fourth one, probability of A and K, means probability of getting an ace card and a king card. Because only one card is being selected from the deck. Either you make it A, an ace card or a king card, but not both. A card cannot have K and A symbol on it. So for that purpose, you can write this one as probability of A. It is called intersection K. This is no possibilities or no outcomes of that one by 52, that is equal to 0. 0. So let us see that Venn picture of that one, Venn diagram, because you see there is no overlap of these two circles. Why? Because a card cannot be both ace and a king card. That's why they are separated. They are disjoint. They are disjoint. Here not A, it is event A containing four outcomes. Diamond ace, heart ace, club ace, spade ace, like that. Because diamond and hearts will be in red color, clubs and spades in black color. That's why I wrote like that. Number of ace cards will be four. Here, K. K is the event of getting king card. Four types of kings are possible: clubs, spades, diamonds, and hearts. Only for idea's sake, this picture is the disjoint events. These are disjoint events. Now we can write down, apply the addition theorem on probability to get the result. We want now probability of K union A, or now the result probability of A union K. We want to find out. As per addition theorem, it is probability of A, probability of K minus probability of A intersection K. It is by addition theorem. By addition theorem. Addition rule we can write. Addition rule, probability of A union K is equal to probability of A plus probability of K minus probability of A intersection B. This is equal to 1 over 13 plus 1 over 13 minus 0. It is 2 over 13. So, hence, what is the result? Probability of getting ace card or a king card when a card is selected from the deck of cards is equal to 2 over 13. Like that, addition theorem can be applied to get the result. Hope this problem explanation is very clear to you. I will brief out any problem if it is given in the probability. First, you identify the random experiment. Then, what are the total outcomes of that random experiment, n value, small n value. Then, you describe the events of your choice. How many events are there by capital letters, and you write down that thing clearly, event name clearly. After that, find out the probabilities of all those events, including the requirement event with a question mark. Then use the idea about the random experiment. If you know, if a coin problem or a deck problem or a picking up a marble problem from a box, whatever it may be, you can give a picture of it so that you get an idea, clarity on idea about that probabilities and possible number of outcomes in that. Later on, pick up the appropriate rule or the formula to be applied to get the required probability in the problem they asked. So carefully you can use it and substitute them, and using simple arithmetic rule we can able to get the result. Do share our channel to your friends and inform them it is effective to learn step by step mechanism to work out the problems. In coming lectures, we are going to see how we are going to use one more theorem called multiplication theorem on probability. All the best.